This video is going to walk through a few stoichiometry calculations. We'll do a few that are moles to moles, and then we'll also do some that involve gram calculations. So let's look at number one. The equation is already balanced, so you don't have to worry about that. So to get started, the first thing we always do is just write down the number that's given. So before I even read anything in the question, I know that I need to write down 0.300 moles of Na2SiO3. So that's sodium silicate. Okay, and so the question asks me how many moles of HF, hydrofluoric acid, are needed to react with 0.30 moles of sodium silicate. So what I'm looking for, right, is moles of HF. So a lot of times what I do in the equation is I underline what I'm starting with, and then I circle for what I'm looking for. So essentially in this question, I'm trying to go from here to here. So when we look at our map here, right, we're always starting with what we have, and then we're trying to get to what we want. And when we're in moles, we can just use our balanced equation and our mole ratio to tell us that. So for example, this equation, right, I know there's an invisible 1 there. So for this equation, I know that I have 1 sodium silicate for every 8 HFs, right, or hydrofluoric acid. So I can use that ratio in my calculation. So I'm starting with moles, Na2SiO3, so that means that has to go on the bottom. My equation tells me I have 1, and then I'm looking for HF. So I'm going to put 8 on the top, right, because I'm trying to go from what I have to what I want. And now when I do my calculation, multiply across, I get 2.4 moles of HF, right? Because I'm always multiplying the top, dividing by the bottom, okay? So if we look at our next question, okay, it tells me I'm starting with 0.5 moles of HF. Okay, so I'm starting with moles, but it's asking me for grams of sodium fluoride. Okay, so I'm going to erase the information from my last question. I'm going to do the same thing. I'm going to underline what I'm starting with, and then I'm going to circle what I am looking for. So I'm going from here to here. Okay, so same thing. I'm starting with moles of what I have, so I'm going to use my equation, right, to get to moles of what I want. So I'm going to have moles of HF on the bottom, and it tells me that there are 8, and then I'm going to have moles of sodium fluoride on the top, and it tells me that there are 2. So I'm using my balanced equation to go from what I have to what I want. But since this question is actually asking for grams, I am going to have to go one more step on the map here. And then remember, the way that we get there is we use the periodic table. Okay, so if I have mole of NaF, I know that if I'm going to go from moles to grams, I just have to look at the periodic table, and I'm going to add up the molar mass of NaF. So when I add that up, I get 41.99 grams, okay, which is what I'm looking for. So now my units cancel here, my units cancel here, and I can multiply the top, divide by the bottom, and I end up with 5.25 grams of sodium fluoride. Okay, so here we go. We're going to do the next one. So I'm going to go ahead and erase what I have here so we are starting fresh. Okay, so it tells me I'm starting with 0.8 grams of HF, and I'm trying to get to grams of Na2SiO3. So I'm just trying to see how much can react. So I'm starting with here, and then I'm going here. Okay, so I'm doing this. So in this case, I'm starting with grams, so I can't immediately go into my mole ratio because I'm starting with grams. But again, we know how to go between moles and grams. We just are going to use the periodic table. So if I have grams on the top, I know that I need grams on the bottom. And if I add up hydrogen and fluorine, I end up with 20.01 grams. And I know that that's always equal to 1 mole, right? My molar mass is always grams in 1 mole. Now that I have my moles, so I just went from here to here. Now that I have moles, I can use my balanced equation to go from what I have to what I want. So my equation tells me that I have 8 moles of HF, and then I'm trying to find, right, that invisible 1 mole of Na2SiO3, sodium silicate. Okay, and then now that I'm in moles, I can do that one last step to get to grams because the question's asking for grams. So I know that in 1 mole, if I add up my molar mass, I get 122.07 grams, and this is of that sodium silicate. Okay. So if I multiply the top, divide by the bottom, I end up with 0.60, or 610, sorry, 610 grams. Okay, so we're just using our map, right, to go from whatever we're given, whatever we have, to what we want. So depending on where we start, right, that's why I always write down with what I start with, because if I start with grams, I know I have to go to moles, and then I can use my ratio to get to what I want. Sometimes you start with moles, and so you can just go straight into using that ratio. Okay, you just have to follow where you are on the map. So let's look at another one. Okay, and I'm going to write the map kind of really small. Maybe I'll write it down here on the bottom. So we know that we can go from grams to moles using the periodic table, right? And this is always what we have. And then if we want to go to moles of what we want, this is where we're going to use our equation, right? Our ratio. And then we can also go to grams if we need to using the periodic table. Okay, so let's look at A here. So again, this equation is already balanced, so I don't have to do any balancing. So I'm just going to start with what I'm given. So 0.4 moles of C6H12O6. Okay, and then what does it tell me I'm looking for? I'm looking for moles of CO2, so I'm going to here. Okay, so I'm starting here, and I'm trying to go to here. So I'm in moles. Okay, so I'm right here, what I have, and I'm trying to get to what I want. So that means I'm just going to go, I'll try to use a different color. I just have to go like this, right? So if you want to, you can pause it here and you can try to set this one up, and then you can hit play and you can kind of check your work. So if you'd like to do that for this set of problems, that might be a good chance to kind of check where you are in these calculations. So since I have moles of C6H12O6 on the top, that's what I'm going to put on the bottom. And then my equation tells me I just have invisible 1. And I'm looking for moles of CO2. And my equation tells me I have 2. So I'm going to put a 2. So it's a 1 to 2 ratio. So now I'm ready to multiply the top, divide by the bottom, and I get 0.8 moles of CO2. All right, let's look at B. So again, I'm starting with 7.50 grams C2H5OH. Okay, so let's erase where we're at here. So in this case, I'm starting here, right? And what does it tell me I'm trying to find? Grams of C6H12O6. Okay, so I'm going from here to here. So if I'm starting with grams, that means I'm starting here with grams, and I'm trying to find moles first. So the way that I'm going to do that is I have to put grams of C2H5OH on the bottom, and that's always going to be equal to 1 mole because it's my molar mass from the periodic table. And so when I add all of that up, I end up with 46.08. Okay, so now I've gone from here to here. So let's erase this last little question. And this is where I kind of hid a question because we're not going to worry about it. Okay, so I went from grams to moles. Now I'm ready to go moles to moles. So I'm going to use my mole ratio. So if I have moles of C2H5OH at the top, that means that's what I need at the bottom. And my ratio tells me I just have 1. Oh, sorry, that's the wrong one. Got ahead of myself there. Here's my C2H5OH. So my equation tells me I have 2 of those for every 1 C6H12O6. Okay, so I have a 2 to 1 ratio there. Last up, moles to grams. So remember, this is where I'm going to use my molar mass. Since I have moles on the top, I have to put moles on the bottom. And since it's always grams in 1 mole, if I add all of that up, I get 180.18. So now I can multiply the top, divide by the bottom, and I end up with something like 14.6 grams. Okay, so if you want to, pause here, okay, and then try C. So it's exactly the same way that we just set up the previous problem. It's just asking for different things. Okay, so you're starting, right? Underline what you're starting with, circle what you're looking for. So in our equation, that means we are starting here, and then we are looking for that. So I'm going to start by putting what I'm given. And then since I have grams on the top, I know I have to put grams on the bottom. And I know that that's always equal to 1 mole, because that's just the molar mass, right? My first step, periodic table. Now that I have moles, now I can use my balanced equation. So my equation tells me I have 2 for 2. So I'm going to say 2 moles of C2H5OH for every 2 moles of CO2. Now that I'm in moles of what I want, I can go to grams. And I know that 1 mole, moles on the top, mole on the bottom, is 44.01 grams. So now I can multiply everything on the top, divide by everything on the bottom. and I end up with 7.16 grams of CO2. So that's pretty much all there is to it. As long as you can follow the steps on the map, just remember that whatever's on top has to go on the bottom, so that helps you keep your units straight and help you keep track of when to put grams on the top and when to put grams on the bottom. And then as long as you follow your map, then you should be able to set them up each time with the correct steps.